everyone. Welcome to AI Intel. I'm very excited to have you all here tonight. This series is all about showcasing what founders and builders in AI are creating and getting the community a place to connect, share, and inspire each other. Think of it as a space where ideas and get shared raw and real, not polished pitches, as you can see. It's not polished at all. So let's take a quick look at how tonight will flow. I'm Cedric Vidal. I'm your host tonight. And what I do in the day for a job is trying to make AI look cool at Microsoft. Alongside me are Zina Batul, software engineer, Pamela Fox, a fellow cloud advocate, which those days means basically AI advocate, and Anaga Todabagi, product manager. They are the ones helping me tonight make this event a success. So big thanks to them. Now, thank you. Now let's talk about tonight's speaker. Tonight we hear from two fantastic speakers, and I weigh my words. First, Sacha Morard, co-CEO at Edgy. He built the company together with Gilles Raymond, who happens to be a close friend of mine, and honestly, it's not every day that you get to see a close friend go on tackling such an unknown and important problem. I'm really excited to hear Sacha. You're going to see it's pretty amazing what he's going to talk to you about. Then, Jason Corkim. Founder and CEO of Repeat Data. Jason's a great example of why this is a community event and community driven. He first came here as an attendee, we connected, and now he's going to be up on stage tonight sharing his journey. And that's really the spirit of AI Show and Tell. Anyone in this room could be a future speaker. So please, if you're putting something exciting, come talk about it to me, and don't hesitate to reach out and submit a talk. Then, after our two speakers are done, each one of them is going to have roughly 17, 18 minutes. We're going to have a panel and Q&A for 35 minutes. This is one of my favorite parts of the evening because it's where we move from presentations to real conversation. We're digging into the hard questions, exploring nuances, and sometimes even having speakers debate over their ideas. And this is where we come in. We want your questions to shape the panel, so don't wait until the end. If something sparks your curiosity, during the talks, scan the QR code and drop your question in right away so that you don't forget it. We'll read them in the discussion during the Q&A and the panel. It's the audience question that take the conversations we're having and surprising in a valuable direction, so you basically shape what we're going to talk about. Please make sure to jump in. Before we get there, though, I want to thank the partner who makes this event possible, our sponsor. A big thank you to Microsoft for Startups for supporting AI Show and Tell. If you're building a startup, this program gives you access to Microsoft's latest AI models and enterprise-grade developer resources, including AI Foundry, Azure AI, OpenAI models, and the ability to bring your own custom models into production. It's redesigned to help founders accelerate experimentation and scale faster, so just scan the QR code to learn more and join. And beyond sponsor support, this event is also part of a larger global network called Global AI Community, which has chapters around the world. This is the San Francisco chapter. But if you travel, you will find others globally. Scan the QR code to join and stay connected locally. And now let's have a look at upcoming events. The first one is going to be in San Francisco. Will be on October 8th at the GitHub headquarters. So we will be back to our usual venue. Today at 555 is exception. And the theme will be AI, voice, and emotions. This is going to be a fascinating one, exploring how AI can interpret, generate, and even feel emotions through voice. RSVP with the QR code and to lock in your spots. And for the first time, AI Show and Tell is also going beyond San Francisco. We're expanding to the East Coast. On September 29th, AI Show and Tell will be at the Microsoft Research Lab in New York City. And the focus will be on browser agents. If you have friends or colleagues in New York, send them the link to have them scan the QR code to RZP. And yes, that brings us to yet another QR code. Send them the link or have them scan the QR code on the next slide. Let me show you how you can get this whole deck afterwards. No note taking required. So the two last QR codes. Tonight's deck will be available in a couple of days. You'll be able to grab it either on the Azure AI Founder discussions on GitHub or in the AI Founder Discord. Choose your poison. And yes, this is really the last QR code of the evening. I promise I've said QR code way too many times. All right, with that, let's dive in and welcome our first speaker, Sacha Morard, co-CEO of Edgy. Please, a big round of applause for Sacha.
Imagine touching something really hot. Let's say this chair is really hot, okay? Did you see? Okay? You don't wait for your brain to process the information, right? It's your reflex that pulls your hand away instantly. And why? Because it's about survival. If you waited for your brain to analyze surface temperature, you'd get burned. This is the reflex mechanism. This is a decentralized, distributed system wired for speed. It doesn't wait for permission from HQ. It just acts to protect and to survive. We often treat AI as a brain, powerful, complex, and increasingly intelligent. So we have chatbots, vision API, recommendation engine, real-time personalization, all happening over HTTP interface. But when this brain lives only in the cloud, every interaction becomes a round trip to the data center. Slow, but it could be costly as well. It could be vulnerable to distance and latency. And here is the problem. We've built brilliant AI models, but we are often serving them like it's 2010, centralized, monolithic, and sitting behind computes in US East 1 zone. So, brain alone is not enough. To be complete, the brain needs the senses, the spinal cord, the nerves, the muscle, and the spinal arc, which is the reflex. And for modern digital application, we need the same. So let's play a game together if you want. So what is the brain in a digital modern application? Any guess? LLM? Sorry?
The server?
Yeah, server, exactly. LLM server, so backend, the model, or the cloud. What are the senses? Client process. Exactly. So the front end or the agent, the client side, the browser. What are the nerves? It's easy.
Network.
Yeah, exactly. The network. And finally, what is the spinal arc? So the reflex.
Some caching mechanism.
Great. Good. Edge computing is the reflex system for the web. Instead of acting on a distant server like a brain, logic happens right at the edge, not on the user's device, but close to it, at the edge of the network, like a reflex, fast, local, distributed, efficient. And in the body, the reflex is a survival mechanism. In a modern application, it's a performance mechanism. So just a little word about what we do at Edgy. Edgy is an edge component platform. So it's a kind of CDN, right? Like Cloudflare or Fastly. But we believe that the future of edge computing has to be as modular as possible. So that's why our platform is basically a runtime of WebAssembly components, WebAssembly edge native components, open source. So the goal is to move technologies from the client side to the edge or from the cloud to the edge when it makes sense. So today I'm going to explain to you how and why edge computing and WebAssembly could help to improve the performance of modern AI applications. I'm Sacha, co-founder and co-CEO of Edgy. I have the pleasure to run and to build this company with Jules, which is the other co-founder. I have a strange career path. I used to be a musician for 6 years, and then I was so struggling, so I had no choice to change my life. So I decided to learn how to code, and I became developer, and then CTO for several companies, and then entrepreneur. So let's talk about the life cycle of an AI product. We all know that to build an AI, you need first data, then train a model based on that data, and finally run inference on the model, right? Do we agree? Okay, perfect. So let's start with the fundamentals, data collection, because AI is only as good as the data you feed it, right? So if you train model wrong data, you're pretty sure that the performance will be bad. Yeah, garbage out, which is a concept that appears in 1957. So it's a long time ago. It wasn't made for AI, right? Which is strange. Old school. Yeah. So when we talk about AI data, everybody is thinking about internet scale data sets to train LLMs specifically. So Wikipedia, books, websites, PDF, images, and so on. But here is the thing. What I call business AI models, they don't need that. So if you are building an anti-churn prediction, recommendation engine, or lead scoring and things like that, you don't need the full internet. And let's be honest, nobody can say that Airbnb or Netflix recommendation models are not critical for the business, right? So what you need to train those models is something much closer to home. It's user behavior data. Every click, every product interaction, every conversion, that's the pulse of your business. And without it, your models are houseplant. Historically, we've collected this data with the client-side SDKs in the browser. Google Analytics, Explorer, Amplitude, and so on. A bunch of JavaScript libraries that run in the browser. But there is a big problem with that. Do you know what is it? Don't see it.
Efficiency.
Efficiency, right? Exactly. Because most of that data is never collected. Between 30 and 70% of user interactions are lost. For this usage, client-side libraries has become too fragile, easy to block, and impossible to fully trust. Why? For multiple reasons. Ad blockers, cookie health, firewalls, unstable connectivity, Safari, Brave, and new agents that's browsing, that scroll the content and so on. In other words, if you train models on this data, your model is built on noise, blind spots, and bias. So, as I told you before, at Edgy, we move technologies from the front end to the edge. And so we capture this data at the edge of the network with WebAssembly component. And this makes the data collection way more efficient because it's unblockable. So you can use the same tool you've been using before, Google Analytics, for instance, but now operated at the edge. So moving data collection to the edge enables to capture 100% of the data. And this is where it gets powerful. With complete data, business AI models become dramatically more accurate. And that's the difference between a model that kind of works and a model that actually drives revenue. And that's what we do with our customers. Going back to the AI lifecycle, let's talk about training for a second. So to be candid with you, AI training is not going to happen at the edge. Training requires tens of thousands of GPUs working for weeks. So that's a job for the cloud or on-premise supercomputers. So let's move on to inference. Improving the performance and the user experience here matters a lot. So how can the edge help? Inference is usually GPU bound, right? But there are several parts of the inference process that are CPU bound. And you can offload those processes more easily to the edge. I'm going to share 3 examples today: tokenization, RAG, and semantic caching. Everything I'm going to show is the result of our research. And don't hesitate to visit our blog. We published a paper today about the research. And the paper is more detailed than my presentation, of course. So let's take a look at tokenization. Tokenization in itself is pretty fast, much faster than GPU inference, sorry. But it happens all the time across every input. So if you're running a system at scale, you're burning a surprising amount of CPU cycles just slicing prompts into tokens. Typically, the GPU works on a batch of input token, and specifically to make the most out of the GPU. So there is a lot of tokenization happening before the batch can be processed. What if you could tokenize at the edge? This would allow you to distribute tasks over hundreds of nodes. Each node would handle a small subset of the tokens, and the amount of byte that would have to travel over the network would be radically reduced. So that's what we did in our research. We built a tokenizer WebAssembly component and ran some experiments to measure the potential savings. And as you can see, the tokenized prompts are up to 40% smaller, resulting in API requests that are up to 20% faster. Really interesting. At scale, that means a better UX, of course, and substantial dollar savings. So if you're using a LLM API that costs a lot, and you want to save money, this is what you should probably do. Now let's take a look at RAG. So let's say you're the owner of an e-commerce website, and you're building a chatbot for your customers, but the model doesn't need to have access to the entire product base. It needs the relevant part of the products catalogs related to the prompts, right? So step 1, you need to build a pipeline that indexes the product, turns it into embeddings, and store them in a vector database. And at query time, it fetches the right products to add them as context to the prompt. And here is the interesting part. RAG and inference are 2 very different things. Inference needs giant GPUs. RAG logic can run on much lighter CPUs, which means you don't need to run both at the same place. The faster you run RAG, the faster the user sees results. And if you operate RAG logic at the edge of the network, retrieval happens closer to the user. So by the time the request hit the GPU, it's already enriched with the right context. So that's what we did in our research. And we built a WebAssembly component to distribute RAG to the edge, and it can double the speed compared with the centralized configuration, and it can save 350 milliseconds of latency. So again, you can see the article on our website. Okay, that's the full result. Then let's move on to semantic caching. So whether you're building a website with or an AI system, of course, caching is a really good asset, a really good strategy to optimize the performance. And the question is, how do we adapt caching to AI? Because caching for assets, statics, web page, and so on is really easy. Caching for AI is harder. So first, you want to keep some creativity. You don't want every answer to sound like a copy-paste. Second, you need to avoid false matches, because two different prompts could be treated the same, but only if they are slightly different. So the challenge is, how do you cache without killing creativity? And without introducing errors, of course. So let's start with the same RAG example for an e-commerce chatbot use case. In that example, there are two main results you could cache here. Two. Can you see where? Can you guess where?
The retrieval and then the answer.
Yeah, exactly. The retrieval on the vector database and augmented prompts. So, more precisely, you can cache the vector database results using the embedding vector as cache key. It's pretty standard. So, yeah, pretty standard. Or you can cache the LLM response itself with the same cache key. If it's done correctly, this makes the whole pipeline faster and, of course, cost-effective. We have not conducted any research on that, and to be honest, I don't think it's really compelling. It can work for very repetitive use cases, but outside of that, the hit rate seems low to me, and the risk of irrelevant answer is pretty high to me as well. So it's possible, but we need creativity. Big CDNs like Fastly or Cloudflare are exploring this space, which is interesting, but again, let's take a bit of time before moving on that phase. So what we saw that in the human body, the brain is powerful but not fast enough for everything. So that's why we have reflexes. In digital system, AI is the brain, but without reflexes, it could be slow, costly, and fragile. At AG, we built a reflex system for the web. We already offer analytics at the edge to get rid of this bloody SDK and to collect better. We offer now edge functions to build any kind of workload that run close to the user. And we are soon releasing AI workflow for low latency inference. And this is a modular edge platform that captures the right data, run the right logic, and deliver the right response instantly at the edge of the network. And the future of AI doesn't live only in the cloud, in the giant brains. It lives also at the edge, because intelligence without reflexes is thought without action. Thank you very much.
Perfect. Thank you. Yes. Perfectly on time. And you even had 10 more seconds.
Well, thank you, Cedric, for invitation. Really happy to be there.
You're welcome. I mean, what we're talking about is extremely interesting, and I have so many questions. Well, thank you, Sasha. Please, a big round of applause for Sasha. So our next speakers is Jason Corkill, and CEO and founder of Rapid Data. And he's going to talk to you about data and analytics. And so please help me applause Jason and welcome him for his next talk. Thank you very much.
Awesome. Cool. Yeah, I'm Jason. I don't have a slide presenting myself. But I'm one of the co-founders of Rapid Data. We're a startup out of Switzerland. I just flew in yesterday. So a bit jet lagged, but we'll get through it. I'll present a little bit about what we do, and then I've got some demos, some interactive demos actually. I'll need 2 volunteers. They'll have to consent to a few thousand people seeing their face, but as long as you do that, we're good. Okay. So what do we do? Well, I stole some slides from a very old picture of ours. So the design's all over the place, but it'll explain what we do quite well. So at the moment, we've got basically the US and the Chinese giants duking it out for the best foundational models, spending, $1 trillion a year on this. They need two things, right? Compute and data, both of those which are necessary for the scaling laws. NVIDIA solved compute. The solution is you throw money at NVIDIA and you have enough compute. The problem is the law also adheres to data, and that's kind of the bottleneck right now. So the solution so far, and you can see this in this very complicated graph, is as the models grew and as we had more compute, what we did is we just pumped the entire internet into the model. The problem is we're kind of stuck now. We use the internet. And this slide's actually a week older than this one, which made me very proud. There was Ely at the last NeurIPS, where he basically called it the fossil fuel of AI. And basically what the thesis of rapid data is we need to go to the source, right? So we've got the entire internet over there, and the source of the internet is all human intelligence. Now, how do you actually capture that? That's the rather tricky part. So we've got 5 million people, 5 billion people. Well, we've got 7 billion people, but 5 of those have a smartphone. So in theory, everyone's connected to a network, and you can reach these people. So the first thought you would have, okay, let's build an app. Horrible idea, because you're going to have to get people to install the app. But there's actually already a distribution mechanism out there so that you can reach every single one of those phones whenever you want. Not whenever you want, but relatively reliably. And that's the advertising network. So every one of you has ads on their phones every now and then, be it on YouTube or Duolingo, etc. And ads, all they do is they replace, they take some of your time, and you get that service for free. But at the moment, we don't use that time very well. But in reality, if we knew enough about you, we could use that time very effectively. If I know you're an AI engineer, I can ask you something. If I just care about how you feel about a certain statement or an object or whatever, that is valuable information that can help us align or evaluate an AI model. And so that's basically what we've built. There we go. So in Duolingo right now, there's a very, very simple example, but there is a 1 in half a billion chance or whatever that rather than you getting an ad, you will be asked to solve one of our rapid data tasks. In the first one, it's super easy, something like this. And then we profile you, we learn more about you, and we start retargeting you. And then from then on out, all of your ads are going to be rapid data ads. So if you do not want to do this, don't solve the first rapid data task correctly. But our cases, it's much more fun than an ad. And that bar is not very high threshold to reach. So basically what we have is we have this really large graph. Every single one of them, we've got a lot of metadata. Most importantly, we have the historical accuracy of this person. How have they responded to whatever tasks in the past? And we now have 6 million people that we have all this information about. So this is a bit abstract. So I'll have the first demo now. All live on the actual system, which comes with its own risks. So I'm going to need 2 volunteers. And we will compare these 2 people with real humans. So 2 volunteers, yes? Yes, okay. So this is more of a toy demo, but it runs on the same, tech as, yeah, I'll just quickly need you here. Okay.
We have no. Okay. That, just look into the camera. I will have a blue screen thing that we'll just do it like this, I guess. Really silly way to do this, but there you go. And next person, please. Alright, there you go. I'll pick it. There we go. And let's got these 2 images. So, what you see here is just a UI demo of our actual API. The API is much more powerful than this. But what you can do is you can try this yourself if you go to that URL. You can upload any 2 images you want. Don't upload porn, please. It does have a filter. And that filter was put in later, after accidents happen. So what we could do is, we can add these 2. Oh, this is high risk. Okay, I'm gonna go to my screenshots, or we just hope.
Actually, you're giving negative ideas.
Yeah.
You're profiting on.
I'm very confident in our filter at this point, so.
Please don't test it. Okay, so we have these two images, and we'll ask real people to choose between these two based on a question. Now, obviously, this is a very simple case, but you can obviously imagine how this could be used for evaluations in real time. So let's say you have an AI model that you're training, and you want to, in real time know, how well is it doing at generating X, Y, Z. You can have people in the loop actually go and check what is happening. So we'll ask a question here.
Wait a second, is this going live? Yeah, this go live. I asked on set up there, yeah.
For only by 6 million people.
6 million. No. Okay, so we'll ask who is. Do we want like a naughty question, like more likely to go to jail?
Similar than which glasses you have your, or do you use it for like user preferences to be like which glass? So
Oh, it has to be controversial. What was that? Yeah. Alright, so that one is the AI checker that passed. Very good. I think the question we asked the AI is this appropriate to show to a 12-year-old? So you passed that. Okay, so we've got the first responses coming in. Every single one of these is a real human responding right now. So we've got someone from Portugal. We've got someone from... Oh, this is... Maybe I see. Yeah, well, actually, as a guy, you are severely disadvantaged at this question. Yeah, I know. But it's fun. Yeah, so every single one of these is a real human responding as we speak. We've got some metadata that we collect. So we even got some of the occupations, etc. Can then also filter. And so you see, it's truly kind of worldwide. So this is more of a toy example. And now, I mean, we'll pull it up later, see who won. But let's show a slightly more serious thing.
She can win. I don't want to win this.
So a more serious use case here is obviously if you use the actual Python API. So we have like a set of 8 different task modalities. These are things like free text, where you can have people just type in responses directly, compare, as you just saw there, or multiple choice, or have people, tap on the image or scroll through a video and like choose a specific time in the video, or you can also do audio or video. It's really whatever you can show to someone within a minute, have them solve, interact with the data, collect that information, and then verify it across multiple people. Because the cost and the speed you saw, like we collect 100 responses in a few seconds, the cost is way low, so it allows you to really get that redundancy or capture the distribution of an answer. So what we're going to do here is something similar. We've got basically 4.0 video image generation versus Aurora, which is the Grok model. And we're just going to check which image has clearer and more readable text. So we've got these pairs. We can define the responses per data point, so that captures the distribution of opinion. But we could also define the confidence if we wanted to. So if we just want to be 99.999% sure that A or B is the more likely to win, we can also do that. So if we run this little snippet here, it'll upload the data. Now, obviously, here I'm actually uploading it from local path files. In a production environment, like with our customers, it's usually already in an S3 bucket, and I just supply the URLs. So yeah, I'll pull up the actual real interface, and you will see the responses here any second. Let's see. Yeah, all right, so we've got the first humans responding. So the latency can be as low as 5 seconds. Really depends on the exact thing you're asking. Obviously, the shortest latency you can have is how long it takes one human to solve it. There's a physical limit there. We can't do time travel. So we did 15 times 15. Quick math, not sure. Responses, so it's probably like 200. 225. So it's 225 responses we're collecting here over the course of 30 seconds or something. And that's not even the maximum speed that's possible. You see it ramps up. So larger orders are even benefit from even higher scale thing, because there's maybe 20-second ramp up time until the maximum speed is reached. So there's all sorts of apps. We don't really care what apps they are, because people always ask me, I mean, you don't want to be on app XYZ because the people on apps probably suck. But we don't care about this. You know, obviously that's an indicator, but we measure the people completely independently. So before you get to solve all of these people that responded here, they had to go through a bunch of tasks just before they ever get the customer task. And even then, there's a score that's attached to them. So all of the results are weighted by, so we've got all the results down here. So all of the results are also weighted by their past accuracy. And that is just then calculated from validation examples. Yeah.
Why are these people solving these puzzles, or like what's the incentive for that?
Yeah, very simple incentives is if you do this, you don't get an ad. And this is more fun than an ad. We let you say 5 seconds or whatever, and we give you some points. And actually, if you do get the interface, in the end, there is a cute animal GIF, which literally boosted our interaction rate by like 10%. Very, very simple. Yeah.
You mentioned weightage, right? So like, is it like different for depending, like for example, if you have a customer that's or just running like a restaurant or something, do you like get more, like, does that vary the weightage for all these people that are the laborers? Like, does it like, label people, like, does it vary depending on who your customer is, or like?
So no, the customer can define this themselves. So in this example, I didn't do any targeting. The more you target, the slower it is. So that's things we're working on so that we can be as fast, even if you target all the way down to just like a waiter or something like that. But you get, like, if I hit download results up here, you'll get a JSON. You'll have every single person listed, what we think they do, what their age is, what their gender is, where they're from. We even have more information that we don't propagate at the moment. But yeah, I've actually got some more demos, so I'll just keep going there. Let's see. So really what this allows us to do, because there's so much scale and so much speed here, we can start measuring the unmeasurable. So one of the big problems here is things like this. So the other day, ChatGPT 5 was released. And this is one of the most famous, statistics and leaderboards on, the quality of the models. And I mean, OpenAI must have been extremely confident releasing this, right? I mean, it went from 4.0, which was the main model, to over here. And literally the next day after their release, these were the headlines. Everyone just wanted 4.0 back. Why, right? And how did OpenAI miss this? And that's because they're not measuring the unmeasurable, which is what do humans want? Like, ultimately, you're aligning to humans. And all the soft things are really hard to measure automatically, right? And if you have a system like this where you can get 10,000 humans, 20,000 humans in like 10 minutes, then you can actually have it as an autocritic for these problems. The other example was the psychophont version of 4.0. Stuff like that slips under the radar. Another very famous example was this one, right, where the Gemini model. So stuff like this doesn't get captured by automatic tests. So for this specific use case, we then also built another wrapper around the API, which I'll quickly show. So everyone knows, does anyone know here the image arena leaderboards? So there's a really cool leaderboards where you can basically have humans choose which model they like more. And then it'll have like an ELO score leaderboard on which models are best. Well, we basically said, hey, wait a minute. We can get the amount of people that have ever done image arena, we can get that in one day. So why don't we just do that ourselves? So we did. This was actually a big commercial success. We were like, what? It took us like 3 days to write. And we're like, we put all this effort into this API, and all we had to do is write a wrapper, and suddenly everyone was interested. So big learning as a startup founder there is like slight tweaks can have big impacts. So what we can do here is we can define the leaderboard. Let's see, I'm running out of hands here. All right. So we can define a set of prompts that we want to test with each one. So that's usually maybe something you're interested in. It could be a very specific set of prompts if you're interested in those, or you can just have a smaller set of prompts. Here it's just 3, just for demonstration purposes. What we can then do is we can, we can create a new benchmark with those prompts. Those prompts can also be given tags so that we can filter by them afterwards. And then we can create leaderboards on this benchmark. So a benchmark has the set of prompts, and the leaderboards is the different questions we're curious about. So one question could be which video is more realistic. So we'll add that. One question could be which video looks better, which video better matches the description, which video has more errors and looks more like AI. So we've got all these different leaderboards. And now we can then add, the models. So we'll add, what do we have here? Year 3, we'll add Pika 2.2. So I've got this all pre-generated, obviously. And we've got Sora. So we'll add all these. And so now you can imagine, we have 4 different models, or 3 different models with the 3 same prompts generating. And now we'll figure out a leaderboard of which of these models is the best. And this is already, as I'm talking, is already running. So we can pull it up here. What is the admin dashboard? Don't look too closely. All right. So we've got the 3 models, and they're computing now. So we've got all the things. We can see, what does it look in the 2 others, and it'll sort itself, of course, these different leaderboards here automatically. And that's actually already collecting responses down here. So this one's not too cool to see because it's not full yet. So I'll just quickly show you. What do we have? I've got so this one checks how well do models generate faces. So here we have a full leaderboard with a couple 10,000 responses that just tests how good does it generate faces. We got the same for, let's say, got too many. Let's do this one. So here we've got the leading video leaderboards. So very similar to the image arena, but completely internally. If a model producer like Luma Labs wants to, check one of their internal models, they can just run a script, and within a few minutes they'll have their position in the leaderboard, which tracks the one on LL Arena very, very closely. Yeah. Then I have no more time. I've got one more demo if I'm allowed to. I'm just going to do it, and then he can come over here and rip it out of my hands. This is a bit of a... 2 minutes? Thank you very much. Very kind man. So one last thing. This is more of an experimental feature that we're playing around with. What we want to be ultimately is the layer between AI and human intelligence. So the AI thinks about a problem, and it wants humans as support. So let's say you have an AI that you give it the task, hey, find a cure for cancer. So it wants to maybe get a survey of 5,000 people here. It wants to ask 300 people that are doctors. It wants to, whatever. It can get those responses from those people in real time during inference time. And we already have a first version of that. So if I got knocked to chat, replicate, please don't go to this URL right now. It will crash. This is very much Claude Code's work. So we'll initialize the client. And so now we could do, for instance, let's see. Run a study on the acceptance of AI. All right, and now we gave the model human use, an MCP, and it can go and get itself feedback from humans from anywhere in the world. It can ask specific countries. It can ask people from specific places, and it can run a study all by itself, just based on human feedback. This will take probably 3 minutes. So I don't have enough time, but I did run it before. So I ran the same one here. It went and asked way too many people, and I already see that I probably should have formatted this slightly differently. But it asked a whole bunch of different questions and collected all the data, and then basically generated a report. Okay, Jesus Christ. Oh God, another one. Okay, let's go. The 2 minutes are going to be up before I finish. What? And I asked a lot of questions. Okay. There we go. So in the end, it ran a study by itself with real humans. I think this one took roughly 5 minutes to run. And it figured out, what people's concerns about it are, if there's geographic differences, etc. Yep.
Let's see the results of that. For the criminals.
Oh, yes, of course, of course. I show all this cool stuff, but really all we care about is this. Oh, I'm sorry, man. You're going to jail. I mean, we can see it. Yeah, wait, you say it's biased? Let's check, okay? Let's see. Only males. Oh, okay. Or maybe you're more popular with the girls? A little bit. I don't know. It can...
I think the smile is actually.
Yeah, it's
The smile, yeah, my bias, I'm a little bit.
Well, I think humans are biased machines.
Yeah, of course, but that's what we want to measure, right? We want to measure the humans. Okay, so people between 40 and 49, I think. She should go to jail. All right, cool. Thank you very much. Yeah.
Silly question. How much is the cost?
So we do starting at $2 per 1,000 human responses, which are delivered in a minute. Yeah, it's we try to see it as a paradigm shift in how you can use humans, just because of the cost factor. So you can easily, like, for instance, Lumen Labs is a customer of ours. They just, whenever they have like the concept of a new candidate model, they're just like, let's throw it on the leaderboard.
Okay. Well, thank you very much. I'm blown away, to be honest. This was there was an exceptional demonstration. It's incredible. And we're going to move on to the Q&A. Before we do that, please a big round of applause because that was very amazing. Let's set up the chairs for the panel and Q&A and really get started. So we're starting the Q&A, the panel with Sacha Morat here, co-CEO of Edgy, and Jason Corkill, CEO and founder of Rapid Data. To be honest, I was blown away. And I was watching at some of the reaction in the audience, and I think I'm not the only one. So I have prepared some questions, but I'm going to have to improvise because it's pretty exceptional. First, let's start with your question. What's your name?
Eugene.
Eugene.
I'm the CEO of a startup at Healthcare Data. But a lot of the work that we have to do has to deal... Well, thank you. The work that we do has... Okay, I need to learn how to switch up on my brain. Okay, never mind. So we have to deal with a lot of data engineering. And the question I have first is for Sasha. With respect to the product that you develop, the solution you develop, the routing, the whole data pipeline engineering, how much effort are you putting into that right now? Or this is something secondary to you? Is at some point in time you're going to be looking into that?
Routing all the data.
Do you mind repeating the question just in case we don't hear on the real?
So the question is, how do we put the effort on the data acquisition on our side, right?
Data acquisition, but also routing. There was something that you mentioned in your presentation about routing data based on a function, i.e. RAG is CPU bound, inference is GPU bound. How do you do that sort of routing mechanism? Let's put it this way. It's simplistic.
Okay. So basically the company started with data collection. So our use case was to serve the data collection better than today. So moving the client side SDKs, analytics SDKs actually, so Amplitude, Xpanel, Google Analytics, to the edge for better efficiency. So that's our main use case. Then actually we're working on several others, and what I showed to you just recently about RAG and inference at the edge, especially the low latency inference, could be a huge asset on our side as well. So we are not putting a lot of effort right now. We are doing research for now, but in the next few days probably we will release something. Yeah.
That's better. I don't know what. How did I really be?
Yeah. Does it answer your question?
Yes, there's more to discuss for sure.
Yeah, for sure.
Well, thank you for your question. Then Pamela, I see you posted a question. And since she's the only one, nobody else used the question submission system. Everybody was asked question live. Okay, well, Pamela, go ahead.
Okay, you do a mic. Okay. I was just trying to understand the cost savings with the doing the tokenization, because you said like, oh, okay, if we do the tokenization at the edge, then we send the tokens for the inference, then we'll save money on the hosted LLM. But usually what the LLMs are charging for, they're charging per token. And as far as I know, I don't think you save money by sending in tokens. Or maybe I also don't even know if that's an option for most of the hosted LLMs, because most people are using, hosted LLMs versus their own trained LLM. So I was trying to understand the cost savings you were proposing with the tokenization at the edge.
Yeah. Great to take this one.
If that was works out.
Okay. Yeah, it works, but a little bit. That's a really good question. To be really honest, I don't know exactly. I'm pretty sure that some LLMs, some APIs are buying not only tokenization, not only tokens, but as well the compute in general. So saving computes for sure is saving dollars. But there is a lot of different business models in front of that as well. But I'm not sure about that. You're right. Saving costs in inference, saving time, basically saving costs. And if you are hosting a model by yourself, for sure, moving computes to the edge will be cost efficient because the edge is, cheaper than the cloud.
I feel like if the tokens are not making it all the way to the hosted LLMs, and there's some caching mechanism in between where the inference is happening, if you're not hitting the LLM directly, then perhaps that would be cost savings.
Yeah. The comment is about, just to repeat, the comment is about with caching, of course, we're saving some requests that is not sent to the LLM. So for sure, caching is saving a lot of money at the end. But if it's effective, it's efficient, sorry. And to be efficient, caching result coming from an LLM is another story. It's a bit challenging. So that's why it's.
Yeah, because with.
For the second.
Hello? Okay, that one works. Because with caching also, recently it seems like the usage of AI will go more towards personalization, where and with all of the context engineering and what to bring into the context of the LLM is highly customized to the user in order to personalize the experience. In which case, caching is going to be tough.
Yeah, you could probably cache some part, but again, if you are asking to the LLM what's the capital of France, or is Paris the capital of France, of course you can cache the result. But this type of question is really rare.
I do wonder though. I feel like I catch myself doing this. I replace Google with I'm replacing Google with the LLM, right? And I do catch myself quite often asking these kind of questions. So of course, you're right. The moment it's a more complex question, you probably don't want caching in between. But even if you can just capture 20 or 30% with caching, or maybe even less, even just 10%, I mean, the scales we're talking here are massive. Yeah. So and especially also video and image generation at the moment, right? Caching basically is the new stock footage in that case, right?
Yeah, and you think about real-time events, like say at Tableau 8, the top events that are happening or the most trending topics on Google. If those are cached, it seems like.
Yeah, you think about Google actually has, the statistics on search term interest over time. And you can see there's a relatively large stack of the same question being asked.
So if I say today's weather San Francisco, that might be asked very often. You can cache that, right? Today's weather San Francisco.
Yeah, exactly, yeah. So the question in the crowd was things like, what's the weather in San Francisco today? Can you cache the couple?
Day in that was when the time you asked.
Yeah, it can only be cached for a short time, I guess.
Yeah, because then you look at the tools.
Well, that anyway works. So I'm actually curious if you can go in any detail about how you track your users that are actually doing the in your studies or that are actually answering the questions. How you verify that they're going to be strong candidates, and just any additional details on like tracking over time. If you see any users fall off or stop participating in a strong way, I would just love to hear more about it.
Yeah, so the tracking is quite simple. So the whole advertising industry basically relies on tracking to make any sort of money. So we kind of just piggyback on that. So roughly 80%, 90% of traffic has an advertising ID. So that's easy. And that's persistent across applications, even devices in many cases. For the rest, you can fingerprint them based on metadata. That works pretty well. We don't care who you are in person. So the advertising industry usually cares much more. So from a privacy perspective, they're much more of a concern. We just care what type of human you are. We care about how well you answer tasks. So what we could do with this ID is we could track you over time. We can also retarget you. So the moment we realize, hey, you're someone that's answering favorably and consistently, then we also retarget you because you've become more valuable to us, which funnily enough actually makes it cheaper because usually retargeted ads become cheaper over time because usually you don't want to spam someone with the exact same ad over again and again. So basically what we do is we build a profile based on your historical accuracy. How consistent have you answered? There's a score that goes up. The higher you score, the less often you get what we call a validation task. But the higher the penalty is if you do screw it up. So if you're at like 0.95 trust score, our score is between 0 and 1, and you screw up, then you get a relatively large ding. And basically, we have the global score, which is just general vibes about how good you are. And then for instance, certain customers, in our case, for instance, Luma Labs, there is a separate score just for Luma Labs and their specific way of thinking about the problem. Yeah.
But since you are able to dispatch the questions to such a huge amount of people, isn't the problem of trusting diluted, compensated by a series of large numbers?
Yeah, so of course, there's one of the things you can have is you can cross-validate any answer you want to a degree that usually wouldn't be possible. So, and this is also, this is more about startup life, but when we talk to customers, the largest cross-validation they would usually ever do is maybe 2 or 3 because of the cost would be so prohibitive. And we're like, guys, you can do like 11. I don't think it's relevant to your bill at the end of the month if you do that. So that's really true. Obviously, the better we are at base accuracy, the less cross-validation we need. And that's good for everyone involved. And then it also comes to, if you are looking for just a binary truth, like the correct answer, like is this a dog or a cat, right? Then you don't really care as long as you have the information about how accurate someone is. You can calculate the confidence. But if you're interested in the distribution of answers, you of course want to keep the noise level low, and there it's very important that we filter these people. And honestly, this works quite well, right? Like bad actors show up very, very quickly, and then they just get discarded. We have no interest. They have no interest. We part ways. That's fine. You also asked about drop-off. That's not really something we see. Usually people recognize that if they screw it up, they're going to have to watch ads, and that's enough of a threat, I suppose.
And I guess just to, and I feel awkward, I'm still holding the microphone, so I have the power to ask.
If you don't mind dispatching the mic others to... We can circle back if that's okay after.
Oh, deal.
Thank you. Because other people want to ask questions.
Thanks for the time, guys. Question for you, right? It's essentially a three-sided marketplace. So maybe it's a cliche question, but how did you do the cold start, getting enough companies wanting to use the product, people involved, and then, you serving the infra? Yeah, so we were very conscious of not building a two-sided marketplace. In the presentation you saw, my bad example was, let's build an app to reach those 5 billion people, right? And you'd be in an endless game of trying to get people to install the app while getting enough customers to supply, these people on the app that have to be compensated in some way. So the advertising system already exists, right? And it's an open auction platform, and we could just plug into that. Now, there's a lot of asterisks and caveats to making that work. But we didn't have to go to like 2,000 different apps and be like, please, can you put Rapid data into us? Right? Like we can buy directly. So we're on like Duolingo, we're on Wattpad, we're on Candy Crush, a lot of the apps, For a while, one of our bigger apps was also Grindr. That was a funny one. So really, that's what we tried to solve, not to have that two-sided marketplace points, which kills most companies. But the main thing is also the concept here is reach any type of human, which would be very, very hard if you had this two-sided marketplace problem that you'd have to solve.
I'd like to ask a question. We can circle back if that's okay. So one thing in common to both of you is that in both your cases, you came up with an idea which is pretty incredible that one might not necessarily have thought about. And in your case, leveraging the ad network to use as a transport to do labeling. In your case, thinking about the problem that there might even be data lost when you collect. In both your cases, I mean, those are ideas that are not common. I mean, pretty hard to come up with. How did you think about it? I'm interested in having both your feedback as a founder, as an ideator. How did you come up about it? And how did you come up to wake up one day and be like, damn, that's amazing. I need to create a company about it.
Then go first. Yeah. Well, that's a freaking good question. I'm not sure to have the perfect answer. Otherwise, it should be really easy to find to start a company. But anyways, when I had this idea with Gilles, I put my brain in entrepreneur mode. That because I wanted to leave my previous job, and I wanted to become entrepreneur as well. So at the same time, I was saying to me, okay, you have to find an idea. So I was focusing on my day-to-day problem as a CTO of a newspaper. And so I found, okay, I have problem with data. I was talking with Gilles at the same time about the same problem. And so, okay, and browsing ideas like that, it came up in a night. I don't know exactly why, but it went like that. Yeah.
Yeah, I mean, I think a lot of the best startup ideas are usually born out of personal frustrations. In our case, it's probably a combination of personal frustrations and like one of those magic startup idea moments. Catalyst of beer as well was involved. So basically, I mean, all the founders were AI engineers, and we just always saw that whenever you needed human data, that was the part when you had to step back from your project and your computer, and you had to go and email or like human interaction. You had to like go and email people, and you had to go and find vendors and deal with them. And very often the vendors also were rather difficult to deal with. And it wasn't just programmatic and instant, right? Even if it was programmatic, it was more programmatic in the sense that you'd set up the order and then it's sent off, and then next day it'll be ready, rather than kind of like ping in an LLM and you get a response back. That's kind of what we wanted to solve. And the real when Rapid Data idea came was I was having a beer with my co-founder, and I was complaining about this problem, and he was complaining that his superior intellect was being wasted on advertising and Duolingo. And I was like, well, that sounds like a good combination there. And I think it was a reverse startup idea. Usually when you have a startup idea, you have the idea and it's like the most brilliant thing you've ever had, right? And you're like, damn. And then like the next 2 weeks you think about it and you realize all the stupid reasons why it's not going to work. And when we had the idea, I very well remembered that we're like, man, that's a stupid idea. And then we thought about it and we're like, wait, okay. So like the advertising market is an auction platform. Okay, that's kind of convenient. And then we're like, like there's already like playable ads and everyone hates them. So okay, that worked. And so like the more we thought about it, we realized, oh, this is actually a good idea. And then we started building Rapid Data. So that's our backstory.
So for Rapid Data, I have a question about scaling specifically for both ends correctly. So I feel like a lot of the value that you were positing for LLMs would be training. And from that perspective, like this would lead to a large data set, but the demos you showed were quite granular. What are do you already have this built, or what are you building so that you could then translate these like large data sets into, you know, such rapid user response? But then also, do you predict a potential for a limit in, you know, user responses when large data sets are inputted in order to get like the value of, you know, having hundreds of millions potentially having to answer the same question?
Yeah, this part I'm not too worried about. So we can do the maximum speed we've had, and like the only reason we haven't gone higher is just because we don't have the clients for it yet. Is we can do 1 million responses in an hour, and we could go faster, but at that point we'd have to like go and change some stuff in the infrastructure, which is not quite necessary right now, because there's 5 billion people. Almost everyone sees at least 10 ads a day on average, is I think a statistic I saw somewhere. The threshold to reach here before we ever exhaust this source is like we'd have to be at billion ARR more. You know, like I once calculate like the digital advertising space is roughly 1.5 trillion a year, I think, something like that. And if we're at 100 million ARR, worst case, we're spending 10 million on the advertising supply. It's a drop on a hot stone, right? So from a scaling perspective, this is really not an issue. At the moment, we have a cold start issue. So if all of our clients immediately right now requested that be a cold start, that would take 5 minutes. But that's solvable, right? That's just we haven't solved it because it hasn't been all that necessary so far. So from that side, I'm really not worried. The funny thing is, what we're learning is as the models are becoming more and more like information complete, the shift is actually the focus is shifting on like the softer human aspects, which makes us much more relevant now in that regard.
Thank you. For Rapid Data, Jason, do you see your platform outside of advertising, not just for advertising? In healthcare, for example, in large population, sort of questioning a condition of human health, social determinants of health, for example. Of course, the incentive model will have to be completely different. But have you ever considered that? Has anybody approached you with something like that? Just curious.
So I'm not sure if the mic works, so I'll just quickly repeat, I guess. So the question was whether or not there's other sources or supplies that we could have for human responses, not just the advertising. So our end goal vision, where we're like $1 trillion company, is that we are just the interface between AI or AI agents and the humans. So whenever whatever the models are, they need feedback from humans, be it whatever way during inference, that they can get it through our system. So the easiest way for us to reach something that approaches that right now, without having the two-sided market problem, is going through such a distributed network as it exists, right? But ultimately, if we reach that kind of size, it'd be very interesting to have other modalities of things that can go into the funnel. You could imagine the system just goes and calls people, right? It'd be a bit whack, but there's a few other ideas that are out there, right? So
do that.
yeah, I can't promise. Yeah, so there's a few options there, right? We just want to be that interface. What we have done for the medical space, as an example, is you saw that there was like the occupation was also listed, right? And so that's data we collected. And what we did is we were curious, can we just get doctors? And what we did is all the people that said they were doctors, we like took them aside and asked them only medical exam questions. So like we took them from like the German final exam and medicine or whatever. And people that got like 99% of that correct, we put them into like the verified doctors list. And then we like asked them, we just got on Hugging Face, we found a data set of x-rays and we had the people annotate the x-rays and it was correct. And we're like, that's kind of the prototype of what we really want to be, where it's like you can get the exact type of human you want basically instantly. The problem is at the moment this is too slow with the scale we're at right now.
And that's, I guess, where the law of large numbers kind of falls apart, because you can't just ask the general public about health questions.
Yeah, but there is millions and millions of doctors. So in theory, you can still have the law of large numbers. It's just an infrastructure change we still have to work on. Yeah.
I actually have a question if nobody else. Okay. I was wondering, like, how do you like, for the human respondents that you have, is it in various languages that you're imposing the questions? Like, how are you selecting, like, the apps that you advertise on, the countries that you do it in? Because I feel like there's a lot of inherent bias that can come in for that, right? Like, if, for example, you're only sampling, like, English speakers or something, like, so how are you accounting for that? Or is that also dependent on your customers? Like, do they say, like, what kind of audience they want responses from?
Yeah, so there's two sides, as you said. Obviously, so the customer can define if they only want people that speak XYZ. So if they say just English speakers or just people that speak, I don't know, Hindi. The system translates automatically. That's the default. It has to be overwritten that it doesn't. So it will translate plus show the original language at the same time. So that's how we deal with localization. And then the last question was, do we prefer certain apps? So we don't care about apps. We care about the people. We ourselves track if someone is reliable, and we ourselves make that decision. So people always go, oh, aren't you worried that people from app XYZ are unreliable? No, I don't, because if they went through our funnel, I don't care if they play the dumbest, like, it's funny, like the smartest people play the like dumbest games on the phones, right? So this is really not an indicator of the quality of people you might get.
But do you ever like regular the respondents and you're like, okay, the data set is leaning towards one age group, for example, so to target like a younger demographic. So we're going to advertise on, say like, not like Facebook is for older people versus TikTok is for younger people, things like that.
Yeah. So we try to be just roughly general. So if you do no targeting whatsoever, the responses coming in should be more or less distributed across the normal population. We don't necessarily guarantee that, but if you could set it so that it guarantees that. Yeah.
I have another question for Sasha. When it comes to inference at the edge, you mentioned RAG, but usually a RAG system, you're having a discussion in which the past answers has an effect on the answers that the assistant is going to give you. It uses as input what's retrieved from the chunks retrieved from the vector store, but also the history of messages, which means it requires some kind of writing system, and at the scale at which you operate at the edge, Is that something that you have started looking into? You have an answer, or is that still up in the air?
We do think about that for sure. And when it's about building a business AI model, especially for recommendation, for instance, you need to refresh and to update your vector database really frequently and in real time. So what we are thinking about, what our research is about, how you put all the data in real time to your database, to your vector database, that is used in your RAG system. And for sure, it's a challenge to do that at the edge. Not exactly at the edge, but to distribute those data collection to the edge and to do the RAG directly at the edge. But yeah, for sure, we are looking at it.
I actually have a question for him. I'm curious, like I saw some cool numbers, right, where you reduce certain costs by 40 or 20%. How is that in relation to the compute cost, right? Because if it's like 0.111%, like Claude and OpenAI won't care to make this optimization, but like, do you have an understanding of what the ratio there is compared to the compute, like the final compute in the server?
Yeah, basically, of course, if you are running a workload on a GPU, it's for sure more expensive than to run this compute on a CPU. But for sure, it has to be compatible with CPU as well at the same time. So then running a CPU workload on a cloud provider is not that cheap today. But running the same compute, the same workload at the edge level is cheap because it's distributed and it's made to be not up and running all the time. At the edge, you launch a workload and you shut it down directly. So the cold start, it's really, really fast. And that's how we made our platform. So in 0.4 millisecond, the compute is started, run it, and you shut it down. So that's made for distribute a workload everywhere and to be cost effective at the same time. So I don't know exactly where we can save money, but for sure, if we are able to select some part of the inference and to run it at the edge, as we did on our research, for sure it will save a lot of money.
So I saw that web browsers, they're adding a local LLM API to the ECMAScript specifications of JavaScript, right? So with the idea that in the future, people will all be able to like run local models on the machine. So, I guess I'm thinking 5 years from now, which models do you think will be running on our clients or browsers, right? Like our senses, which models will be running on the edge, which will be running at a server?
Which is certain is that the huge models are going to be smaller in the next future. So we don't need to run those kind of models if you need if you have a specific need. You need specialized models in the next future. And as soon as the model is becoming small, you can run it elsewhere than the cloud or on a GPU. But it's a challenge today because all the models are pretty big. We have some research to run inference at the edge directly. So to run the full inference with the model and run it at the edge directly, it's really challenging. We can do it. We already did it. We can do it. But in terms of performance, it's not really effective. Why? Because the model is still big. But in the next future, we will have some small models really effective, trained on good data, and so really effective that can be launched and operated at the edge directly and operated at the client side level as well. In the next future, in 5 years, probably, we will be able to stream from the cloud to the edge to the client an inference. So starting from the client probably, and then to the edge, and then to the cloud where the network is on, is warm, and when the compute is there and so on. Yeah, probably.
So I have another question. You mentioned, oh, sorry, there was a question. I missed it.
I think it was a question. Yeah. Well,
I went before.
well, you're back. Yeah.
Thanks. Does that work? Oh, yeah. I took profession for Sasha once, right?
Maybe please put it closer to your mouth.
Is that better?
Yeah.
Okay, great. Sorry about that. Sasha, first, you mentioned that there may not be a immediate tangible benefit between Sept capturing, particularly if they'd be heavy, and you just reiterated that again, saying, I have to keep the whole element at the edge. What's the point? But have you ever considered use cases where you have, but I think we spoke briefly, a non-federated model that would be distributable technically? I yet to move some of that, what was monolithic, to the edge, and then literally say, if I had an LLM dedicated to Pacific Heights and an LLM dedicated to Soma, I want it to be segregated by definition for alignment interests. So the LLM doesn't need to carry anything other than things and so on. Yeah. There have been cases where that distribution change. I have one more follow-up question for you, but I don't know if you want to take that one first.
Can you summarize it for me? Yeah.
So the heavy thing to be a work is really interested. See the function. Sorry, let's try again. The bit you haven't optimized seems to be to do with both the weight and the size of the fully vectorized scale LLM model, weighted against the fact that you were decentralizing it. Yeah, I wouldn't necessarily need to copy that. For example, I want all the political data about San Francisco. I will segregate by 800,000 citizens across 20 zip codes, 7 voting districts. And I know there's no edge conflict. I know the things that know things about Soma don't care about things about Pacific Heights. So have you ever run into use cases where you have natural federation, natural segregation, natural distribution? Does that make sense, or am I?
Yeah, geographic, for instance.
Yeah, geographic, but in such a sense that you're literally saying, I may want to, say in the worst case alignment scenario, I say, okay, here comes now big fat data set the guy in China, and we the people are going to defend ourselves by literally distributing copies of anything. Yeah, in the spirit of the rhetoric down to my
Yes. I think it's more relevant to think about distribution than caching, about inference, model, and so on. Because distribution of data, of the models, of the specification of the models, for instance, seems to be way more effective and way more aligned about the use case, the today use case of running an inference, running a prompt, and asking something to a model, for instance. Yeah.
May I? Just one more? Yeah.
Okay. Yeah, one more.
Okay, very quick. Okay, suppose it's very quick. Lots of demo and stuff, right? But it's like, so your user profile, do you inherit ontologies from the advertising network that you can't do anything about? So does your customer say, here, I've got some ontologies that's a union of everything, advertising gave me, and here's the things I'm learning.
Yeah.
With my given, I'm assuming you've got a trusted individual down there.
Yeah, exactly. So we have metadata we get for free. That just comes from the network. So where are you? Like we actually also get latitude and longitude information of varying degrees of accuracy. That's how you got that map that was right in the beginning of my slides. That's just us mapping all the responses on the world. So country, device, model, all that kind of stuff we get for free. But we don't get information like age, gender, occupation. So we ask that ourselves and then verify it over time. So first time we ask you, and then we'll ask you again. And then if that, of course, your gender can switch, but if it switches 4 times, most likely this is not legitimate. So then we just reduce the confidence in that key part of the metadata. When it comes to occupations, that's actually much cooler because that one you can actually verify. You can go, basically at the moment, the way it works is there's a tree. In the beginning, you'll be asked, is it skilled manual labor or is it, something in healthcare, something that you had to study, whatever. And then it goes down the tree until, there's a specific occupation. And then in theory, what we can then do is ask specific questions that only an expert in that field could do to then verify that that is true. That system is only up and running for medical things at the moment, but not for any other occupation. Yeah.
Yeah. There's a question. I need to ask one last question. That's okay. No. You go ahead.
Yeah.
You could make it quick, like thoughts on VC, no VC, especially like one of your ideas feels like you can start making money out of the gate. So how did you think about how long you wanted to go bootstrapped versus easy money?
No, I'm a big believer in raising money actually. Maybe I haven't been bitten too badly yet, but there's limits to what you can do with bootstrapped, and this is a very, very, very fast moving field, right? You can try to bootstrap, but you will never be able to exponentially change what was happening as quickly as you could do with VC money. So that's my personal opinion. It really much depends on your business model. But we're in a field where, in half a year things are different. And bootstrapping that is very, very difficult. So yeah, that's my view on that.
That was a very good question, actually. So the question I've been wanting to ask both of you. So it happens, my boss, Satya Nadella, I don't know him personally, sadly, said a while ago now that SaaS was dead, that the future of everything we know was agentic, like agents, everything, and just databases as APIs and agents. That's all. No more web UIs, no more SaaS. For both of you, that vision has a huge impact. I'd like to get your position on this. Do you think it's true? How you see the impact of that vision on your business? Yeah.
I'm not terribly bullish on this. I think agents will do a lot, but ultimately the economy is for us. Right? What's the point otherwise, right? I guess. I do think, especially here in San Francisco, there is a little bit of doomerism almost about it. But I like, obviously it's basically a circle, right? The circle it used to be just humans, and now we've got this part of the circle is AI and the rest is still humans, and that part of the circle is going to get bigger and then hopefully never go all the way.
I need to.
Yeah.
I need to make my question more precise then, because I think behind that statement and that vision lies another thing, which is that when he said that SaaS is dead and UI is dead, I think what he means is UI as in static UI. And we had actually a founder recently, and he's gonna hate me because I'm blanking on the name of this very funny logo green. I forgot his name. They're making a framework to use generative AI to create UI on the fly, depending on the question. And so basically, the UI is not static; it's generated by the AI. And so I think that's what also is meant underlying that statement. So basically, the disappearance of static UIs.
Yeah, this is very interesting. Thanks for the clarification. I'm not sure. I think that is a rather long time frame. I think humans are also horrible at anything that's inconsistent, right? Like, okay, here in the room we're probably half decent with it, but like, if the button in WhatsApp moves, my mom is lost, yeah? Even though the button looks the same, and it's still on the screen, but it's on the left-hand side instead of the right-hand side now. At the moment, these models are not terribly deterministic, right? And so your UI would look different very often, right? So, what basically I believe happens with generative UI is it allows you, there's so many processes in the world that someone has to do repetitively, but there's not enough people that there's a SaaS for it, right? Like the threshold of enough people that would buy this is just not large enough. Now that threshold now goes dramatically lower, right? that is where I see the real power here. You can have the sauce for that very specific thing you're doing that only like 6 other people are doing. This is where generative AI is super powerful, but it won't regenerate that UI every single time you're going to use it. It has to be static from then on out, if that makes sense.
On our side, we do believe that in the next future, website is going to disappear, mobile application as well. Unfortunately, of course, but that's the future. But at the end of the day, it will still network. The network will be there. So the exchanges between an agent to another, the exchanges between an agent to an API will be there. And that's called the network. And opportunity for us, it's an opportunity for us because, of course, the exchanges between an agent to an API, for instance, as a publisher, as a website, as a brand, I want to know the users that use my service coming from an agent, coming from anywhere. And so that's the network. And so everybody here needs to do more things at the edge level. That's why for us it's a good opportunity.
Well, thank you very much. You said you didn't hear what you said.
I said I've been best.
Okay. Well, thank you very much. We're past time actually for the panel, but it was so interesting with so many questions. And to be honest, I think a lot of us tonight were so blown away with what we saw that it was worth it. We still have 21 minutes to continue informal discussion and have a drink, and there are still some pizzas and stuff to over there. So thank you very much, well, I look forward to the next event in San Francisco and the one in New York. You had the dates. Hopefully you register, and we see you over there. Thank you very much.
Thank you very much.